All right, thanks for joining everyone. Here for another tips and tricks for VMware Cloud on AWS. And today's topic is accessing AWS Services Made Easy, how to leverage native AWS services and resources from your SDDC. My name is Zach Zumbaugh. I'm a Customer Success Architect and work primarily with VMware Cloud on AWS. And I'm here with my colleague, Caesar.
Hey, good morning, everybody. Cesar Cardenas. I am a Customer Success Architect, also working with Zach, and we primarily do VMC, but we're beginning to branch out into multi-cloud, AWS, and Google.
Yep. Thanks, Caesar. So today we'll start out with a couple of questions just to kind of see where everyone's knowledge is at, and then hopefully we could bolster that with the information we're providing in the session today. So what services can you access from the SDDC in the connected VPC, S3, EC2, FSX, or all of the above? Just give it a few minutes to answer that. Okay, and let's go to the next. The next question is, how are VMC SDDCs connected to the required AWS VPC? Is it a transit gateway, Elastic Network Interface, VPN, or Direct Connect? All right, should have given everyone enough time to answer. So we'll continue on. So the agenda for today, we're going to cover, we'll go over the poll question. I'm only seeing the answer for poll 2. So how are VMC SDDC connected to AWS VPC? 40% said transit gateway, 3% or 30% said Elastic Network Interface, 30% said Direct Connect. All right, so hopefully by the end of this session, you will know the correct answer. We'll circle back. Poll question 1, what services can you access? 82% said all the above, and 9% each said EC2 and S3. So we'll be covering all those topics today, and as you can see, the answers are already on this agenda page today. So we're going to cover accessing EC2 instances, using the AWS load balancer for SDDC workloads, accessing S3, access FSX through the guest OS, and we'll have a page that will have some links with some resources to get you started. Right, so accessing EC2 instances. So for every deployment, VMC on AWS SDDC has a required native AWS VPC that's connected to it. What is this for? Well, it's really just, it's part of the service. It's a requirement to deploy it. You technically don't really have to use it or deploy anything into it if you didn't want to. But as you can see, as you will come to see throughout this presentation, it's very useful in certain ways. So first of all, you can use it deploy EC2 instances. So it's just a native AWS VPC, and you can deploy EC2 into it and access those EC2 instances from your SDDC. So if you have certain applications you want to run in native AWS, but they're part of a subset of an application where you have VMs also running in the SDDC, they can work together, communicate with each other seamlessly. And I'm going to go into the details here. So first things first, when you're deploying, configuring your connected VPC, you really need to keep in mind, and this is going to be something I'm going to mention a few times just because it's important, is the primary CIDR. So when you deploy a native AWS VPC, it asks you what CIDR you want to use. And this example, we just have XY00/16. So fill in whatever you want for X and Y. So when you deploy that, the maximum size you can set is /16. So that's what we used here. Smallest is a /28. But if you want to be able to deploy other subnets, for example, this one, which we can see is XY10/0/24. You need to make your primary CIDR sufficiently large in order to be able to create additional subnets to deploy EC2 instances in this example. The primary CIDR can't be changed after you deploy a VPC, so it's important to try to get it right the first time. The connected VPC can be changed after deploying the SDDC, but if you had anything running in there like EC2 instances, they will not be able to communicate with the SDDC anymore unless you set up a different path of communication. But that traffic won't be over the E&I. You'd have a brand new VPC with nothing in it. So you want to make sure that you have your CIDR configured sufficiently large. So in the connected VPC, there's a default route table, and this is actually managed by VMware. Use Lambda functions. So that default route table will get updated. As you can see here, it says SDDC networks. Those will be automatically added as you add new networks to your SDDC to the default route table. So the default route table is updated. So if you're going to use a custom route table, a lot of people actually do that for various reasons. You have to update that yourself. So that's something to keep in mind. When that will change is when, so basically the E&I here, that's the connectivity between the SDDC and the VPC. So the route table points at, the SDDC networks point at the active E&I. The active E&I is associated with the host that has the active NSXT edge on it. So whichever host that is, that'll always be in the first cluster in the SDDC, but that E&I will be associated with the route to the SDDC networks. The routing from the SDDC side, as you can see here, is the primary CIDR. That's the only route the SDDC knows about. So it can't route to secondary CIDRs. You can have up to 5 CIDR blocks on a VPC, but the SDDC will only be able to access the primary CIDR. So now to kind of go through the mechanics of actually deploying and using the EC2 instances. So really just deploy them as normal in your VPC in a subnet that is part of the primary CIDR. And once you've done that, you really need to make sure your firewall settings are correct. So in the SDDC, we have a distributed firewall. By default, that allows all traffic. So if you're not using it actively, it'll just be open. A lot of customers are using it to get more granular firewall control. So you would want to make sure that you have your rules set up correctly to allow traffic to and from EC2 subnets. Secondly, you need to configure the edge firewall, the compute firewall. This is basically the same principle. You have to make sure that the traffic is being allowed in and out to and from the EC2 subnet. And then actually the EC2 instances themselves are all associated with an AWS security group. So you need to, once again, configure the access properly in the security group to allow that traffic. As I said, the route table is updated by default. The default route table is updated automatically. So if you're using custom, you need to add the routes there. But the routing in the SDDC doesn't change. It's always going to be pointing at the primary CIDR. So once you have all that set up, really it's just like any other communication. I'll go over the E&I. The E&I is a 25 gigabit interface. So it allows plenty of bandwidth between the SDDC and the VPC. All right, next up. So using an AWS load balancer. So this is kind of an interesting scenario. So you can configure a load balancer in the connected VPC, and it's very similar to configuring an EC2 instance as far as what you need to do as far as networking. So as I mentioned before, make sure your route table is correct, make sure your CIDR and everything is set up correctly, and your firewall rules, because the load balancer will have an IP, and it basically effectively works the same way as accessing the EC2 instance. Excuse me. In this scenario, this diagram, you can see the VMs and the SDDC are part of the pool for the load balancer. And you can also use pretty much a lot of other services associated with networking or load balancing. So in this example, we have the WAF in front of the load balancer, and then we're using Route 53, which is Amazon's DNS service, which has lots of different functionality. So if you need DNS, you could use that as well. So if you had a domain name, you can associate it with the IP address of your load balancer, and so then people can access it, your application from the internet, if you so desire. So why would you want to do this? Well, it's because they're managed components, right? So in AWS, the load balancer is basically automatically configured based on the settings you provide. Same with the WAF and Route 53, so you don't have to deploy virtual machines and things like that into your SDDC if you didn't want to. So it just makes it easy. And also, if you want to bring your own IP, currently that's not supported in VMC and AWS, but you could do that on the Amazon VPC side in order to, if you had a requirement that you had to use your own IPs instead of, random elastic IP from the SDDC. So you could bring that in there, configure Route 53 to point at your IP that you migrated over, and associate that with the load balancer and the WAF in order to access the workloads. So those are two examples of services we use, and I'll turn it over to Caesar to cover some additional ones. Caesar, you're on mute.
Oh, I clicked it, my bad. So the S3 service can be used with VMC on AWS to serve up objects. It can be used to serve up websites. The connectivity, as Zach said, is through the Elastic Network Interface. And then from there, you set up what's known as a VPC endpoint. And the VPC endpoint is set up using an IAM user service consumer, right? In setting up the service, you're able to configure the bucket. You're able to configure bucket policies, and you're able to set up, endpoint policies also as to who can access this bucket. So the VPC endpoint gives it a private IP address inside of this sidecar VPC, which connects through the Elastic Network Interface, and there's no charges for this. This is the benefit of there's no egress charges. The only charges you get for any AWS services is for the service itself, and it gets billed to your AWS account. It won't be part of your VMware VMC account, right? So that's a key point. In the questions, a lot of you thought we connect through Transit Gateway or through Direct Connect. And the thing about this is, yeah, that when it's a VPC out there in your AWS environment, that's normally how you connect. But this is an agreement between AWS and the VMware Cloud piece where egressing data out of this VPC into the VMware SDDC has no egress charges. So consequently, it saves you a fair amount of money for accessing whether it's a website internal. You can still access it through public, but you can access it through private for your VMs inside of the SDDC. So basically, when you go through the wizard, it's done in S3. You create the S3 endpoint, you create the access policy, and like I said, it'll be SNATed through from there to the source side. And as Zach said, you have to go through and configure all the firewall rules, of course, to allow this subnet to talk to that subnet in the sidecar VPC. I want to talk next about FSX services. So there are quite a few FSX services primarily used in VMC on AWS is FSX for Windows and FSX ONTAP. So this is in the sidecar. You're able to create this in the AWS console. You're able to create the FSX service with all its features and use the protocols of SMB and TFS. It also integrates with Active Directory, right? So you're able to create this service and present it back through the an IP address to your users. It says here it's connected into a /26 subnet. I'm not sure that is positive. It could be any subnet, but it will be created in a private subnet. And it's presented to the VMs or the Linux or Windows. It doesn't matter what it is, but it's presented as a share, right? So you just have to map it to this, and your OS is able to see it. None of these FSX products, which you'll see in the next slide, we'll use NFS protocol, are used for mounting, so you can run VMs yet. They're only used for file shares. One of the challenges that they had with FSX is that when it's designed, it's in an availability zone. They spread it across 2 availability zones to make it available, right? And that did not work with VMC because it needed to sit in, the only thing that could come through without the egress charges being charged is in a single availability zone. So they have a single availability zone. That's the one I'm going to talk about for NetApp version FSX. And as you can see here, it's once again, it comes through the ENI. It's in the sidecar VPC. It's in a single subnet now, a single availability zone. They show here an EC2 instance that can access it. It can, as Zach said, that can sit there. So the service itself is configured with a management interface and an inner cluster for changing things in the cluster. And it presents NFS, SMB, iSCSI protocols on a local subnet back to the SDDC. So I wanted to talk about some of the features of it. I said you can do either a multi-AZ or a single AZ. You're still gonna have if it's a single AZ and something happens to that AZ, there could be a challenge, but it saves you all the egress charges of coming out of the VPC. You could build this out in another VPC, but that's subject to all the it has to flow through the AWS networking, which is fine, but this is just a service that's been adapted to work for VMware Cloud. Interesting things about this is how you can, you can go up to 192 terabytes. You can create a volume. The volume is off of the SVM, which is the two parts that make up the service are the SVM and the volume, right? And the volume itself can go up to 192 terabytes. And the SVM, you can have multiple SVMs and multiple volumes. So the virtual machine that serves it up is presented as a service back to either a Linux or a Windows machine. The IOPS and throughput capacity are set during the configuration of the service. And basically, you know, if you want more IOPS, they can give you a bigger machine because it works on the NIC out of the machine. And if you want more throughput capacity, or I'm sorry, I said it backwards. Throughput capacity, they would up the size of the SVM. If you want more IOPS, they would put more disk in. The networking for it is, as Zach said, is through the route table. So it's presented as a in the VPC as a service, and you can set it. It gets a full URL name, but you can give it a DNS name in your DNS service so that it's easily accessible. Encryption is key here. It has both encryption at rest and encryption in flight. So you know, if you have those needs, it's managed through AWS Key Management Service, the keys, and it's set up through you know, access policies. It integrates with Active Directory, so you can have it. You know, this SVM can join your VMs, can join your Active Directory, and be, you know, all the authority of who can access it can be controlled through that. The product integrates with SnapMirror, so you're able to do you know, snapshots and clones of the data. So it's if you're using ONTAP today, it's pretty much the same features. I mentioned Active Directory. Oh, and it can be managed by both the console inside of AWS or through the command line interface, if that's the way you prefer to do it. It's just a general overview of the product itself. The documentation on both the AWS side and the VMC side goes into many different features, much deeper dive than I had time to do here today. But feel free to reach out to Zach or I for any of these products or others if you desire information on them.
All right, thanks, Caesar. Here's some links to resources. So VMware Docs page will find information on how to configure connecting to EC2 S3, things like that. And then we have some really good blogs that are always updated pretty frequently. So any new features like FSX or products you can integrate, those should be some blogs on there. All right, so we value your feedback. If you want to know of any other topics or want to have any other topics discussed on future sessions, let us know. I believe they're going to pop up a poll question. Yeah. So while you all are filling out the feedback survey, if you have any questions at this time of what we covered or any other related topics, feel free to ask, and just put that into the Q&A section, and we'll answer those as they come in. Well, I have one here. I'll ask this to Caesar. Can you connect FSX directly to an ESXi host?
Not yet. As I said, it's only for file shares to a VM. So being able to do NFS like you do on-prem, is probably coming soon, but soon could mean a long time. But it's not there today.
Cool. And we will be sharing these slides out, so don't worry about that. And also the video recording will be posted on YouTube under the VMware Cloud channel. And here's a question: how many VPCs can I have connected over an ENI to a single SDDC? That's going to be 1. So it's a 1-to-1 relationship. Well, each SDDC can only be connected to one VPC. You can connect multiple SDDCs to the same VPC, but you want to keep in mind, keep top of mind your IP allocations there. Because as I mentioned, I'll mention it again, you can only access networks that are part of the primary CIDR. So obviously the more SDDCs you add, if you needed to add more resources on the VPC side, AWS side, then you need to make sure you have enough IP space. All right. And here's some additional resources. So those are links to the tech zone, and it has posted these links into the chat.
There's a lot of reference architectures on the AWS side as how to hook these services up also.
Here we go. We have a question here. Just answer live. Can you replicate an SDDC to another SDDC, possibly connected to another VPC for disaster recovery? Yeah, so we have a product called VMware Cloud Disaster Recovery. I think that's what you're getting at. So you can basically set up DR from from your SDDC to another SDDC in a different region. Now, if you mean replicate the settings potentially, there's not really directly, but there's what we call a fling. It's called the import export tool. This is like a community supported, basically a Python script that allows you to copy the settings from an SDDC and import it into a new SDDC.
Depending on your SLA, how quick you need to recover, you could bring that up in at least in probably no less than 2 hours. But you'd have to have your data. You'd have to have all your data. So it only really holds, the fling only holds your configuration. So VCDR is probably your best for bringing back the data.
There's also, it's not really DR, but more, I wouldn't call it DR because it's the same region, but we could do stretch clusters. So basically when you deploy your SDDC, you can select the stretch option and it will divide up the hosts in 2 different availability zones in the same region to give you a little more resiliency.
That takes it from 3 nines to 4 nines, and it will withstand an AZ failure.
Correct. All right, we don't have any other questions, so thanks everyone for joining. Hope this is useful, and we'll see you on the next one. Thanks.